right tail, etc., two-tailed. And that's what I'm trying to figure out, because then we can just get it since it's two-tail. All right. Inverse norm. Okay. I don't want to keep wasting time here. I can't find this very, very quickly. So what do you want us to do? Do you want us to move to a different question? Do you want me to do it with another calculator? Give you that I can give you the answer with? What would be helpful? Or keep
Which
looking?
calculator would you need?
What I'm telling you, what I'm trying to say is I don't know the syntax that it
Oh,
wants.
okay.
And that's what I'm trying to find, but it's like nobody does it this way anymore. So it's hard to find
Okay.
like the syntax. And I don't have one to like. So what I'm like, do you want the answer or do you want to know how to do it on the calculator? Because I
If you could
can't.
just briefly like talk about it maybe and then work through it, that'll be fine.
Okay.
Or however you feel.
Yeah, I'm just really frustrated I can't find this. So what I'm trying to say is that there's typically like like this last entry, it doesn't like, okay. It really doesn't like this last entry. So here's the problem. The problem is that number is not correct. So what number is correct is dividing the area by 2, because it wants the left tail. It appears that it wants a left-tailed number.
Okay.
Okay, so the way inverse norm works, and I'm writing this in your other, is it wants the area, the mu, and the sigma, but it's always left tail.
Mhm.
All right, so I'm gonna go back to the screen and try to explain that. So what I mean is that, like, since this alpha is for both tails, if you divide it by 2, and that's what I did here in the formula, then it gives you the correct z values.
Mhm.
Okay, so that's where this divided by 2 comes in. So that means that this divided by 2 is that one, divided by 2 is the other, and you end up getting 1.77. It is negative because it's giving you the left z value.
Okay.
Negative z, positive z by symmetry. All right, so the next one here should be better. This one would have been better to do first anyway. Okay. All right, so it says for a one-tailed test, lower tail, that's very important. That means the area is in the left tail. It's saying the area over here is 0.0885, and you want the z value. So you go to inverse norm, you type in your area 0.0885. Now you don't need to cut it in half because it's left tailed. That's already what it wants in the calculator. 0 is the mu, 1 is the standard deviation. So area, mu, sigma.
Okay.
So that's under that second distribution. So why don't you try entering that, and we should get one of these numbers.
Okay.
Might have to do a small amount of rounding, but
It's very cool. And then after I type in the 0.0885,
you got to type a comma for and then the mean, which is 0, comma 1 for the standard deviation. That's always true for a z
do I have to
statistic.
close the parenthesis off after the 1?
Yes.
Okay. I got negative 1.35.
There it is.
Okay.
Okay. All right, so not too bad. Number 13 here is similar. All right, so it says for a one-tailed upper test, and you notice I'm always drawing this. It's an important skill to do. It's saying the area up here is 0.0735. Problem is your calculator, it always wants lower tail. Okay,
Uh-huh.
so if you just go into an inverse norm 0.0735 comma 0 comma 1, all of your ants, like what you're going to get here is negative. You're going to get a negative number
Okay.
because it thinks that you want over here. So the calculator's stupid. It doesn't know what you want. You want the positive value. Now notice all the answers are positive here.
Uh-huh.
So what I want you to put this in your calculator. You're going to get a negative number. You're going to make it positive to correspond to the upper tail.
Okay, I got negative 1.45.
So that means it's positive 1.45.
Okay.
Now another like if you want to get one of these numbers here, you would do it this way. You would write 1 minus 0.0735 comma 0 comma 1, and then it will give you the positive number that you want.
Okay. Okay.
So you have to be comfortable like left tail, right tail, and in between tail.
Hmm.
Okay. Moving on to 14.
Yeah.
Right. Okay, it says in a two-tailed, again, like notice there's this key differentiators at one tail, meaning upper or lower, or is it two-tailed? And then they're giving you some other information. So again, two-tailed here means that there's two areas to care about. Okay. Now the z value of 2.9 is here, but by symmetry, you also make it negative 2.99 here. Okay. Now the p-value, which is what they're asking for, is the area in both tails. Okay.
Hmm.
So there's several ways to do this. Okay. Whenever you want area, you're using normal CDF. And if you remember, it's a lower, it's an upper,
Sure.
it's a mu, and it's a sigma.
Okay.
Okay. Now just think about this for a moment here. If we put in, for example, let's say we put in minus 2.9 to 2.9, 0 and 1 for mu and sigma, it's going to give you the area in red here. Is that what we want?
Mm, I'm
We
not
want
sure.
the black area.
Yeah.
Okay, so that's a problem, right? Like we want it's going to give us the red if we go from minus 2.9 to 2.9 comma 0 comma 1. Okay, that's good. But we don't want that. We want the black area. So what should we do? Well, from class, hopefully they said this a few times, the total area in the curve is 1. So the total area is 1. That means the red and the black add up to 1. So if you find the area in the red, you can subtract it from 1 to get the area in the black.
Okay.
Okay, so that's option 1. So you're gonna do a normal CDF like this, but you're gonna subtract it from 1. Option 2, okay, is to do the normal CDF like we normally do, but you got to do it twice. Okay, you got to go from minus 10 to the 99 to minus 2.9. That would give you that first black area, 0 comma 1, plus normal CDF 2.9 to 10 to the 99 comma 0 comma 1. That will give you the second black area. Which do you like better so far?
I started typing in this option 2,
Okay,
so I could,
go ahead and work that out then.
yeah. Which one would you use?
Option number 3, which I haven't
Oh,
shown you yet. Like the reason I'm showing these 3 options is because they're all valid and they're all ones you might see on a test or a quiz. And you have to be comfortable moving between them basically.
yeah, so I think I got the first option, the 00019.
This one, but did you did both of these for normal CDF?
Oh, no, I just typed in the first one.
Option 1 or option 2? Sorry, I'm just not
I just
following.
did the first part of option 2, sorry.
Okay, but you guys, so that gives you this first number.
But that's wrong, huh?
It's not, it's incomplete. It's like, you also need the second one here.
Okay, I think I would choose option one then.
Okay, so here's one thing you will notice. So what did you say you got 0.10?
It was 0.0018. But if you round it, it's 19.
Okay, that's fine. So this one by symmetry will also be 0.0018 by symmetry. Okay. And the reason is because it's left and right of the same value, just negative are the same. So option number 3 is to double the one on the left, normal CDF minus 10 to the 99 minus 2.90 comma 1.
Okay.
So they're all correct. There isn't like one that's better than the other. It's scenario specific. You have to understand which one do you want to use
Uh-huh.
and why. You have to know, okay, I'm either going to find the middle area and subtract from one, or I'm going to find the two areas of the tails and add them together, or I'm going to find the area of one of the tails and double it.
Okay.
And like you said, it's 0.00189-ish doubled 0.0037.
Okay.
I know that was a lot.
Yeah.
It's I mean, that's what you're doing in this part of the course. It's a lot of these distributions, finding areas, things like that. Okay, question 15. In a one-tailed, lower tail, very important. Lower tail means to the left, means over here. This is the area in the lower tail. The Z value is 2.3.
Mhm.
Okay, so this is ideal because the calculator gives you the area in one tail if you use normal CDF. The
Uh-huh.
lower, remember it's lower, which in this case is minus 10 to the 99. The upper is 2.3, comma 0, comma 1. So this time this gives you that direct area, and that's what we want. We want the lower tail.
Okay. Let me stick that in there. 1 second, I did it wrong. Okay, got 0.98.
Yes, so I've drawn this horribly. I realize what I actually did here. 2.3 on the Z is actually way over here on the right. And so it's actually most of the area, which is why you get that. Good. Okay, so just the moment you feel like you got that down, the
Yeah.
questions get more difficult. Let me just see if there's any more like those. No, of course not. Your homework comes with the practice another. I mean, those would be good to do. If you had time, you can also just wait till you get that practice exam to see what'll be on there. Okay, number 16. So it says the average gasoline price of the major oil companies has been $2.10 per gallon. Because of cost reduction measures, it is believed that there's been a significant reduction in the average price. In order to test this belief, we randomly select a sample of 36 of the company's gas stations, determine the average price of the stations, $2.02. Assume the population standard deviation is 0.19. Okay. All right. So a few things on what are called the null and alternative hypotheses. All right. So typically the alternative is what is called the claim.
Mhm.
This is the thing that you think has changed. So in this case, the claim refers to the reduction. All right, so this is mu has gone down to $2.10. Mu is less than $2.10. The claim, what we think to be true is that it has gone down.
Hmm.
The null hypothesis always has an equality in it. This is where there's some gray zone for me because I don't really know exactly what they want here. So what I mean by that is the kind of the best practice is to go greater than or equal to 2.10. Basically, the other direction is this one. Some courses, though, they want an equal sign in all their null hypotheses. Do you mind checking, letting me know which is correct here so I can give you that answer here going forward?
Yeah. How should I type that in?
There's usually a palette off to the right for this. You can also type, so mu is typically mu, or it's under the Greek letters there. And then there should be a symbol for greater than or equal to. If you don't see it, you can use the keyboard and type in a greater than and then an equal to, and it should convert to a greater than or equal to. Famous last words.
Well, I'm having trouble finding that.
All right, let me share that screen here. I just get weary here of submitting stuff just because it's I don't want to create problems for you. So go to the Greek, and mu is right there. Mu lower, and then you got to keep going here. So symbols, maybe? Nope. Didn't like relations. There it is. Relations. That symbol right there. And then you've got to put a number in. So you could just type that in. So I prefer that you submit these than me, if that's okay. But hopefully that was helpful to see where all that stuff is.
Correct.
Great. Okay, so now we can move on to some other things. But before we do, we have to reread the information here, and we need mu, x bar, sigma, and n.
Okay.
So mu is 2.1. We already have that. We randomly select a sample of 36. So that 36 is the sample size. The average price for the gas for the stations in the sample is $2.02. That's the sample mean. And then the standard deviation of the population is 0.19. So we need those four values to continue here. All right. So B and C, based on this, says to compute the test statistic. In this case, you're using a z-test statistic. It's always x bar minus mu over sigma.
I didn't get the one after for the second part of A.
The alternative is mu less than, u less than.
It's just mu less than
2.10.
I did something wrong. That means the symbol would be going that towards the 2.1.
To the left, but it's not, it doesn't have a line underneath. It's just the less than, not the less than or equal to.
Huh. I tried that, but I don't know why it's not working. I don't know if I have another try or not. I have, so mu, the symbol going, opening up to the left, and then 2.110 or 2.10.
Yeah, I mean, this is, let me just, I mean, this is what we're looking for.
Yeah. Oh, I see. All right, I got it.
Okay, again, part B, you're using a z-test statistic. That should have been something covered in class. The reason you're using z though is because the population sigma is known. That's the main reason here.
Uh-huh.
So you need those four values. You need x bar. X bar is the sample mean, 2.02. Subtract mu, 2.10, over sigma, which is 0.19, divided by the square root of 36. Now, most of the errors are made entering this into the calculator. You need parentheses there and there, parentheses here. The square root will generate its own parentheses that you close, and then you need one more to close the bottom.
Okay.
Without these, you will never get the correct answer. There is another way to do this, but it's worth being able to do this calculation because based on what I saw last time, you'll have some stuff like this on your test.
Minus. It's just a regular minus symbol.
Yep.
Nine.
You have a
Negative 2.52.
okay. So negative 2.53, just rounded there. So that 2.6 rounds to
3.
3. Okay. All right. Now the p-value, again, there's a couple ways to do this. I think maybe that's probably the hardest part is there's so many ways to do it, but if we just are consistent with what we've been doing, the z value is right there, minus 2.53. To determine whether you want the left area or the right area comes from the alternative hypothesis. So since it's a less than, okay, since HA is mu less than 2.10, this less than corresponds to the left tail.
Okay.
And that's how you have to sort of just go through the progressions. Where is my z value? Got it. Is it less than or greater than? Less than is left tail, greater than would be right tail. Now you can go to normal CDF on your calculator. Minus 10 to the 99, minus 2.53, comma 0, comma 1. And that'll give you the left tail area.
Negative 0.841.
There's no way the area will be negative. So we'll check that one more time.
Oh, I added an extra parenthesis. I don't know if that'll do anything, but
The area is always positive. This is always a positive number. It's pretty small. It's probably 0.00 and then two numbers.
okay, I got 0.0057.
Yes. So go ahead and try that. Let's make sure we're on the same answers here are good before we go to D.
Yeah, that's right.
Okay. So before we answer D, there's just it's a really simple, straightforward way to determine the answer. If p-value is less than alpha, you reject H0. Okay. If p-value is less than alpha. So the p-value is what you just found. That was the 0.0057. 0.0057. Is that less than? And what's alpha? Alpha should have been given in the problem. Of course, it's not. Oh, they give it to you in part D. So they tell you that alpha is 0.05. Okay. Now I know maybe the numbers, it could be awkward and all that, but you have to be able to decide, is this number on the left less than this number on the right?
Okay.
In this case, it is. The answer is yes. Okay. When it's yes, you reject H0. Okay. Now there's a little bit more to it that we'll get to, but this is the main principle is this thing right here. The second one is if the p-value is greater than alpha, your book or your classes do not reject H0. There's other wordings you might see in other courses. Okay, so you have to be able to distinguish between these two. P-value less than alpha, reject. P-value greater than alpha, do not reject.
Okay.
So in terms of your answer, you are going to reject. So it's either B or D. Okay. Reject, whenever you reject, there is always sufficient evidence. See how the main difference here is there is sufficient evidence, there is insufficient evidence.
Uh-huh.
Reject always leads to sufficient evidence.
Okay.
It's especially in your class. There's some variations on that, but and you get two guesses anyway. So if you're doing this on your own, I believe you get two guesses. If you
Okay.
can get this part right, p-value less than alpha, greater than alpha, you're down to 2. You know, obviously don't want you to guess on the test, but for homework, you know, you can use the advantage of WebAssign here for that. All right, 17 here. Let me know when we can move on to 17.
That last one was a long one. So it's
Yeah.
17.
Yeah, it's, the next few are like this, but they're very repetitive here.
Okay.
It's the same situation here. Carpet company advertised that would deliver your carpet within 16 days of purchase. That's mu, like that's what they're saying. That's our standard. Sample of 49 is taken. The average delivery time of the sample is X bar. The standard deviation of the population sigma is 5.6. State the null and alternative hypothesis for determining if the advertisement is legitimate. What you're looking for is any language that says that they think the delivery time has increased, typically words like increased, decreased, stayed the same. So when you read this or look this over, do you see any words like that?
No.
Yeah, I agree. So the only thing I see is this word is legitimate.
Yeah.
Legitimate, I guess, to me means stays the same. Okay. So the stays the same is when you don't know whether there's a change. You're not sure whether the change is up or down. You're not sure. Okay. In that case, your claim is a not equal to. Okay. And there's
Okay.
always a number that follows that. In this case, it's 16. The null is mu equal to 16. And I'll summarize all this in a table here at the end if I remember how to do this, if I remember to, but this is the null and alternative hypothesis. Mu equals 16, mu does not equal 16. And the claim is that, well, we don't know whether it went up or down. Maybe it went up, maybe it went down. Just not equal to.
Try those. I just need the equals.
The equal to in the first one and the not equal to in the second. Those should be under the relations, or you can use the keyboard there for the not equal to.
Okay. Trying to find the not equal to.
So you can also type in the exclamation point and the equal sign. That will give you a not equal to.
Oh, okay. Oh, shoot. Yeah, I didn't get any of those right. I
Okay.
did. I went to Greek and I did the mu equals 16 for the first one. And then I
If you
did
want
the,
to, if you want to send over a picture, or I can make you co-host, you can share your screen.
yeah, let me, can I text you the picture?
Sure.
Okay, I sent them.
Okay. Ah, okay. So I think I missed a key word here now that I'm looking back some more time. It says within 16 days. That's the key word there. So when
Okay.
it says legitimate, it's referring back to that. And I didn't see that at first because I just take that to mean, but what that means is that the claim is that it might take longer than that. The claim is that it might take longer. So the other direction is a less than or equal to. So that is likely the issue. That's probably why there was an error. Why it said, hey, we don't like that.
Let me try it. I don't need the exclamation mark, do I?
No, you don't need that now. Just the less than or equal to and a greater than. So the word within means less than or equal to. Like if you've been at work, I'm sure someone's ordered something and you're like, all right, we'll have it to you within 2 weeks. That means anytime up to and including the 2 weeks.
Mhm. Okay, I got that.
All right.
I wonder why it says enter the exclamation mark and equals for not equal.
They're just trying to give you standard like language for various problems. It was in the last
Really?
one as
Oh, okay.
well. Right there. They're just trying to cover all their bases.
Mm-hmm.
So, all right, part B. Part B is to compute the test statistic. Since the population standard deviation is known, very important, that population standard deviation, it's a z-value. Z equals x bar minus mu over sigma divided by the square root of n.
Well,
Okay, so you have all those values. Your x bar is 17.3, your mu is 16, your sigma is 5.6, square root of 49. All right, so go ahead and calculate that for us, please.
one 1.6.
Yeah, 6.3, 1.63 here for 2 decimal places.
Okay.
All right, now just to maintain some consistency with like what we did in the previous problem, the p-value, which it does not ask for, but we can still use here, is 1.63. P-value is the area up here.
Okay.
All right, so you have to go to normal CDF okay, and type in 1.63, 10 to the 99, 0, comma 1. Okay.
Okay.
Actually, that is part C, so that's good. We'll come back to these two boxes in a moment.
Okay, do you want me to type in the normal CDF?
Yeah, go ahead and get that p-value for it. You'll need that for part C.
Is 0.0515. So should I round it to 52?
0.05. I didn't catch all that.
0.0515. That's what it was. But should I
Okay. Yeah, you can try that here. Let me check it on my end as well.
Oh, didn't like that.
All right, so it's 0.0516 with rounding. So you got to go out to that extra decimal place. And you got to decide, does that cause it to round up? And it
Didn't like
does.
that either. Yeah.
Are you doing that in part C?
Oh, no.
Okay.
My bad. Okay, yeah, part C is right.
Okay. Now let's read this together. It says using the p-value approach, test the hypothesis at the 5% level of significance. So you have to encode in your brain that level of significance means alpha. 5% means 0.05. So just like the previous problem, very simple. Is your p-value less than alpha? Is 0.0516 less than 0.05? Yes or no?
Mhm. Um,
And if you're not sure, like I can give you some
yeah,
help guidance on this, but
yeah, I'm not sure. No.
okay. This one is a no. Okay. And there's like a bunch of ways to do it. One is to add some extra zeros here and just start comparing until they're different. You know, when you get
Uh-huh.
to the one, like 0 is the same as the 0, the
Yeah,
5 is the same as the 5, the 1 has that compared to the 0. Well, it's bigger. So no.
yeah.
So this is a do not reject. So a do not reject always, always, always in your case corresponds to an insufficient.
Mhm.
See that word insufficient there?
Yeah. Okay. Okay. You got it.
Okay. Now to go back to part B,
See, I accidentally clicked it on part B first, that answer.
okay.
And then
Yep.
I was like, oh shoot. So then I clicked it on C, but they were both right. So
Good. So we need the test statistic for this. Okay. And what's going on here and what's a little bit awkward is that there's really like two approaches. One is called the p-value approach, which we've been doing, and the other is the test statistic approach. Okay, so I don't expect this to be very clear, but that's what's happening here. We've already done the p-value approach. Okay, so the test statistic approach is since there is 0.05 in the tail. Trying to decide how you know that. Does it? Oh, it does tell you that. It does tell you alpha equals 0.05 in the tail. So this is where you've got to use inverse norm. The area 0.05, 0, and 1. Okay. But when you put 0.05 into inverse norm, it thinks it's left tail. So it's going to give you a negative number. You have to know to make it a positive number because it's right-tailed.
Okay.
So how do you remember that? You know, just more practice. Do some problems.
Let me try them. Negative would be negative.
Well, that's what I was saying. It's going to give you a negative number because the calculator thinks you mean left-tailed. So you have to
Oh,
know to take that negative number and make it a positive number.
okay. So 1.644 it was.
Okay. It might take 1.64, 1.65. I'm not sure what it'll take. Enter none for the unused tail. Okay. Sorry. So this is a little unclear. So the critical value is
Oh,
on the
yeah.
other one. You got to go down to the other one. All right. And this will be none. Is what it looks like.
Yeah, I don't have another chance on that one.
Okay. Now for the state your conclusion, here's the nice thing. It doesn't matter whether you're using p-value or the critical value. These are called two different approaches. They give you the same answer. So
Okay.
since you already know to do not reject, there is insufficient evidence from the p-value, you similarly use that here.
Okay. All right, I got that.
All right, so let's just quickly do like number one here. Probably all we got time for. Get a few quick look at this. All right, so it says the average manufacturing work week in a particular city was 40.7 hours. That's mu. It is believed that a recession has led to a reduction in the average hours in a work week. Reduction means less than. Do you agree with that? Means less than?
Yeah.
So which of these in HA has a less than in it?
C.
C. And it's that simple. If you can
Okay.
determine the claim, that will tell you the direction of the hypothesis.
Okay. And how did you know it was HA again? Sorry.
It's always the claim. The claim is always
Okay.
part of HA. Good question. All right, we do have to stop here.